Good afternoon. Good afternoon, everyone. Good afternoon to all. So, can you see me? Am I visible and audible to all of you? Friends, can you see me? Is my screen visible to all of you? Just let me know in the chat box so that we can start the class. Just type S if I'm audible. Yeah. Okay. Thank you so much. So, let's start the class today. Yesterday, we were discussing on the questions related to aldehydes and ketones, right? Yes. So today we are going to continue with the same thing. So for today, the first question goes like this. So consider the reaction and what sort of reaction is it? So just try to find out whether it is an electrophilic addition elimination reaction or free radical addition elimination, electrophilic substitution elimination, and nucleophilic addition elimination. So what type of reaction it is? So we have studied this reaction under the reaction with ammonia and its derivatives. Just try to find out the type of reaction given in the slide. So in an to an aldehyde, NH2 NH2 group is added, no? So what type of reaction it is? It is basically the nucleophilic addition and elimination. Okay. So who is the nucleophile getting added to it? So who is the nucleophile here? So NH2, just a second. So the nucleophile is NH2 and NH2. So this is the part we are going to add into the aldehyde, right? So RC double bond O H. So this is basically the NHEZ and H plus bond. So separate the H plus and the remaining NHZ is NH and NH2 is the Z component. This is the Z component. Okay. So we have to add this negative component to the carbonyl carbon. So break the bond, add H here and NH2 to the carbon. Okay. So what you will get from here? R, CH, single bond, OH, and in the other side you will have NH and NH. So this is what we have done in the first step. So what is this? This step is called as nucleophilic addition. So this step is called as nucleophilic addition. We are adding the NH-NH2 nucleophile to the carbonyl carbon. Got it? And then we are eliminating the H2O from this reaction. How to eliminate? Just remove the OH and H from the carbon, from the carbonyl carbon and shift this double bond here. So what we are doing? We are eliminating the H2O and finally we are getting RCH double bond NH2. So which is the compound given here in the question. So and second step is called as elimination. We are eliminating the water, so it is called as elimination. Got it? So this is basically the nucleophilic addition and elimination reaction. So option T is the correct answer for this question. Is this clear to everyone? Or do you have any doubt here? If it is clear, just type S. It's clear in the chat box so that I can understand. Or if you're having any doubt or if you want me to repeat, I'll repeat it. Yes. So we can move on to the question number 2. Which of the following compounds will give positive test with tolerance reagent? Acetic acid, acetone, acetamide, and acetaldehyde. So try to find out the answer fast. I'll give you 10 to 15 seconds. Try to find out the answer. It's an easy question. Which of the following compounds will give positive test with tolerance reagent? Tolerance reagent is used to test the aldehydes, right? So what could be the answer? Option A, B, C, or D? No one has got the answer yet. I'm waiting for your response. Try to find out the answer first. So the answer is option D, right? Acetaldehyde. So why do we use tolerance reagent? To test whether the compound has aldehyde or not. So it is used as a test for aldehydes. Okay. So who are the tolerance reagent? Can I have the formula for the tolerance reagent or the name for the tolerance reagent solution? Ammoniacal silver nitrate is used as the tolerance reagent, right? So the tolerance reagent will convert the aldehyde to carboxylic acid or carboxylate ion. So basically oxidation occurs in presence of tolerance reagent. So the ammoniacal silver nitrate is used as a reagent and this will work out, and the tolerance reagent shows positive test only with aldehyde, and aldehyde is given in option D. So option D is the answer. So in option A, what is the name of the functional group we have? In option A, it is acetic acid, right? The formula for acetic acid is CH3COOH. So the carboxylic acid group is present in option A. So it will not give positive test. And in case of option B, what is the formula for acetone? CH3, C double bond O CH3, right? So it is the ketonic part. And acetamide, the formula for acetamide is CH3, C double bond O NH2. So this is amide again. Amide will not undergo, and the formula for acetaldehyde is CH3, C double bond O H. Got it? So only the aldehyde shows or it gives positive test with the tolerance reagent. Okay, got it clear? Shall we move on to the next question? Just give me a thumbs up or type it in the chat box. If you have any doubt, just let me know. Yes, it's clear. Okay, so we can go for the third question. So 2-hexene with O3 and H2 gives the products, and the two products formed in the above reaction are. So what is the name of the reaction? What is the name of the reaction? O3 with the H2. What is the name of this reaction? Can anyone let me know? The chat box. The name of the reaction. It is ozonolysis, right? So the name of the reaction is ozonolysis. So it is ozonolysis reaction. So in ozonolysis, what we have to do? What we have to do? Take the reactant first. The reactant is 2-hexene. And what is the formula for 2-hexene? Hex means 6 carbon. Just write the 6 carbon chain. And between the second carbon and third carbon, we are having a double bond. So satisfy the valency of each carbon with the hydrogen. Yeah. One person has got the answer as option D. JNP Visakhapatnam has got option D. Okay, we'll check whether option D is the correct answer or not. Okay. So CH3, CH, CH, CH2, CH2 and CH3. So this is the 2-hexene compound. And on treatment with O3, and H2O. What we have to do in ozonolysis, just break the double bond, option A, yeah. So just break the double bond and add one oxygen to the first double bonded carbon and second oxygen to the second carbon. Okay, so what you are getting? In the left side, we are having CH3, CHO compound, and the other compound is CH3, CH2, CH2, and CHO. Okay, so what is the common name for the first compound? The common name for the first compound is acetaldehyde. Okay, and what is the IUPAC name of the first compound? The IUPAC name is ethanol. Okay, and coming to the second compound. So what is the name of this compound? What is the IUPAC name of this compound? It is butanol. It is butanol. So you see the options. Butanol and acetaldehyde is given in option A. That is the correct answer for this question. And the acid is not forming, so option B cannot be the answer. And in option C, we are having acetic acid again. No. And option D is the wrong answer because butanoic acid is given. So option D is not the correct answer. Option A is the correct answer. Good. Try to find out the correct answer in the beginning. Okay. No problem, no issues here. So any doubt you have here? Shall we go on to the next question? So we'll go for the question number 4. Given below are two statements, assertion and reason is given here. And the assertion says that the compound can be easily reduced using zinc amalgam, that is zinc mercury coupled with HCl to the corresponding compound. And the reason is the zinc amalgam HCl is used to reduce the carbonyl group to CH2 group. So in the light of the above statements, choose the correct answer from the options given below. So try to find out whether both are true and R is the correct explanation of A, and A is false but R is true. A is true but R is false. Both are true but R is not the correct explanation of A. So what is the answer for this question? Can you think of it for 10 to 15 seconds? So what is happening here in the assertion part? So we are taking on reactant and we are treating it with the zinc amalgam mercury, that is HCl couple, and the name of this reagent is Clemmensen reagent, right? This we use in Clemmensen reduction purpose. And in the Clemmensen reduction, the C double bond O group will be converted to CH2 group. So this is the Clemmensen reduction actually. Okay. And the Clemmensen reagent is used to reduce the carbonyl group to CH2 group, they are saying. What about the reason? Clemmensen reagent reduces the carbonyl group to CH2 group. That is correct. Option A. Okay, let's check. So the reason is correct. The zinc amalgam is used to reduce the C double bond O carbonyl group to CH2 group. So reason is correct. But you see the assertion, here we are having OH group also, alcohol we are having. And the alcohol oxygen contains two lone pair of elements. Okay. When we treat this compound with zinc amalgam in presence of HCl, so the oxygen lone pair gets protonated by the HCl. HCl is an acid, right? So it gets protonated by the HCl and we'll get different compound. That is, here we'll have OH2 with the positive charge and the C double bond O group remains constant there. And to neutralize this, OH2 goes out as H2O, forming the carbocation here, and the one of the hydrogen which is present here will go out as H plus, giving its electrons here, and it forms the double bond. So basically, we'll get the double bond here with the elimination of water. This is the final product we get from the given reactant using zinc amalgam and HCl. Got it? But you see, OH remains constant in the product given in the question. But C double bond was getting reduced to CH. Okay? If we do not have this OH group in the reactant, then the product is correct. If OH is not present here, then we can say the given product is correct for the given reactant. But since OH is present, we would arrive at this particular compound and not this compound. So assertion is false, but the reason is true. Clear? Clear to everyone? Assertion is false, but the reason given here for the Clemmensen reagent is true. So option B is the correct answer for this question. Question is little bit tricky, okay? But it is an easy question only. Just you have to go through the question once or twice before arriving at the answer. Got it? You have any doubt here? Or you want me to repeat it again? If it is clear, just type yes so that I will move on to the next question. Otherwise, if you're having any doubt, just let me know. I'll repeat it again. Can I have the thumbs up or the response from your side? Students, are you there? Okay, I'll move on to the next question. The product formed in the following chemical reaction is. The product formed in the following chemical reaction is. So a compound is given to you and NaBH4 is acting on it in presence of ethanol and it forms the product. You have to find out the product formed from the reaction. So who is NaBH4? It is an oxidizing agent or reducing agent? Sodium borohydride. Sodium borohydride is a reducing agent. It is a strong reducing agent. Okay. Try to find out the product. Take 5 to 10 seconds. Try to find out the product soon. What is the answer for this? Option A, B, C or D? In option A, both the C double bond O group, that is the ketone group as well as the ester group has got reduced. In option B, ketonic part remains constant, but ester is getting converted to alcohol. And in case of option C, here in ester, oxygen is getting removed and ketonic part is getting reduced to alcohol. And in case of D, only ketone gets reduced and the ester remains same. So what is the correct option for the given reaction? Not able to find out the answer? Okay. So the correct answer for this question is option D. So NaBH4 is a strong reducing agent, but it will reduce only the ketones. It will reduce only the ketones and not esters. It will reduce only the ketones and it will not reduce ester. So this is the ester part, right? R, C double bond O and OR. So the ester carbonyl system will not get reduced. So this is the ketone. R, C double bond O and R we are having. The C double bond O will be converted to the secondary alcohol. So ketones always gets reduced to secondary alcohol, no? So the C double bond O will be converted to CHOH. So option D is the correct answer. The ester part remains same. So is this clear? Is this clear to all of you? Just give a thumbs up. Just give a thumbs up. Okay, we'll go for the question number 6. Go for question number 6. Thank you so much for your response. And find out the answer for question number 6. So there is a compound given to you. And the name of this group is called, the given group is called. Such an easy question it is. What is the name of this group? So we are having a carbon, and to the carbon, some two alkyl groups are attached. And in one other side we are having CN, and the fourth side we are having OH. So what is the name of this group? We are having CN and OH. Tell me whether it is hydroxynitrile, or it is hydroxycyanide, or it is cyanohydrin, or hydroxyisocyanide. This compound you would have come across in the nucleophilic addition of HCN to the C double bond O system. Huh? So what is the name of this group? This group is called as cyanohydrin. This is called as cyanohydrin. Okay. It is not called as hydroxynitrile or cyanide or isocyanide. It is called as cyanohydrin. So option C is the correct answer. Okay. So let's go for question number 7. So which compound would give 5-keto 2-methyl hexanal upon ozonolysis? So what is ozonolysis? Reaction with O3 is called as ozonolysis, right? So just try to react this given 4 options compound with the O3, and let us check which compound is giving 5-keto 2-methyl hexanal. So take the first compound given in option A. What we have to do, just break the bond and add oxygen to both the double bonded carbon. So what we will get here, we are having a carbon, and here one carbon is there, and this is CH3, and here we are having an oxygen, and here carbon-carbon single bond, and I'll write that, okay, I'll write here, and to this one CH3 is attached, and this is the double bond. So this is the product we are getting from the option A. So how to name this? First, we have to number this carbon chains, no? So both are ketones, so you can go from either of the ways, from left to right or right to left. So this is numbered as carbon number 1, 2, 3, 4, 5, 6, and 7. So this is the ketone, right? And we do not have any methyl part. And also we are having hexanal. And hexanal is given. Option B. Okay, let's check. So hexanal means it is an aldehyde. So both contains ketone. So option A cannot be the answer. And try with compound B. Break the bond and add oxygen to it. So what you will get, CH3, C double bond O, and this is the methyl group. And here we are having the carbon, and to that carbon, oxygen is added. And the other one is hydrogen. Okay, which is already present here. This is the hydrogen. Okay. Now, how to number this? Aldehyde should be given the first priority, na? So this is carbon number 1, 2, 3, 4, 5 and 6. And to the second carbon, we are having one methyl substituent attached. So what is this? So in the parent chain, we are having 6 carbon, and the second carbon, we are having CH3 group, and in the fifth carbon, we are having the ketone group. So it is 5 keto, 2 methyl, hexane, al. Since this is the aldehyde, it is hexane, al. 5 keto, 2 methyl, hexanal. So option B is the correct answer for this question. Got it? And from option C, what you will get? You will add oxygen like this, and we will get here one CH3 group is there, here one CH3 is there, and double bond, and here. So we'll get CHO here. So we are getting 1, 2, 3, 4, 5, 6, right? So we are getting 5 keto, 3 methyl hexanal here. So this is 5 keto. So the position of the methyl groups changes. So it is 5 keto, 3 methyl hexanal. So that's why option C is not the correct answer. And from option D, what we get on adding the oxygen like this. So here CH3, and here you're having one more CH3, and this is the double bonded part. And here CHO group is there. So 1, 2, 3, 4, 5, 6. So to the fourth carbon, methyl group is attached. So what is this? This is 5 keto, 4 methyl hexanal. So that's why option C and D are not the correct answer. Option B is the correct answer for this question. Clear to everyone? Okay. Let's move on to question number 8. The major product C of the following reaction sequence will be. So, you're having a reactant that is enal. Alkene and aldehyde containing compound is called as enal, right? So, this is propanal. This is called as propanal. And the enal on treatment with sodium borohydride and SOCl2 forms A. And A on reaction with benzene and anhydrous AlCl3 gives B. And B on treatment with DBr forms C. So you have to find out the compound C from the given reaction. So try to find out A first. What is A? So it is undergoing reduction. Sodium borohydride is used for the reducing purpose. So which compound is getting reduced here? Which compound is getting reduced here? The CHO carbonyl group will be reduced on treatment with NaBH4. So you'll get CH2 double bond CH, and the aldehyde always forms primary alcohol, right? So CHO will be converted to CH2OH. So it forms the primary alcohol part. And this is compound A. And this compound, sorry, it is not compound A. This is the reactant that you are getting on treatment with NaBH4. Then you have to treat this with SOCl2. So what you will get on treatment with SOCl2? SOCl2 gives you Cl, and here Cl nucleophile, and the OH nucleophile will be substituted by Cl nucleophile. So we get CH2 double bond CH, CH2 and Cl. This is compound A. Okay. So SOCl2 is the source to give the Cl. So this is compound A. And this compound A is reacting with benzene with anhydrous AlCl3. With anhydrous AlCl3. What is the name of this reaction? So the name of this reaction is electrophilic substitution reaction. So who is the electrophile here? So from this compound A, you will get CH2 double bond CH, CH2 plus as an electrophile. So this electrophile goes and attacks one of the hydrogen present in the one of the carbon present in the benzene. So we will get the C6H5, CH2, CH double bond CH2. So this is the electrophilic substitution reaction, and this is compound B. And compound B on treatment with DBr. So what is D basically? D is the deuterium, right? It is an isotope of hydrogen. So like HBr, it is called as DBr, D plus and Br minus. So we have to add this DBr to the double bond. How to add this to the double bond? What rule you have to use here for the addition of DBr to the double bond? We have to use Markovnikov's addition, right? So what is Markovnikov's addition? The negative part of the molecule goes to the carbon which has less number of hydrogen. The negative part of the adding molecule goes to the double bonded carbon which has less number of hydrogen. So Br minus is the negative part. So this is the double bonded carbon. So break the bond, and in the first carbon only we are having only one hydrogen. That is very less number of hydrogen. So Br goes here and B goes here. So what you will get? C6H5, CH2, CH, Br and CH2D. So where it is given? So it is given in option. Deuterium is going to the last carbon and Br is going to the second carbon next to it. So it is given in option C, right? So option C is the correct answer. So CH2, CHBr and CH2D. Got it? So any doubt you have in question number 8? Or if it is clear, just give a thumbs up or let me know in the chat box that it's clear to you. I'll move on to the next question. Shall we move on to the next question? Okay. So this is question number 9. Identify the product for the following reaction. Ketone on reaction with ethylene glycol in presence of HCl forms a compound, and you have to find out that compound. Basically, you will get a ketal, right? You will get a ketal, and what is that? Option A, 2 products you are getting, and option B and C, 1 product is formed and no reaction. What is the correct answer for this question? So what you will get? Reaction of alcohol. Reaction of addition of the alcohol nucleophile to the carbonyl part. So which is the correct answer for this question? Okay, let's try to solve this, okay? So CH3, C, double bond O and CH3. This is the ketone named as propanone. And to this, we are adding the CH2OH and CH2OH. Just I'll write the structure like this, just for your understanding, okay? So this is the ethylene glycol and this is the propanone given in the question. In presence of HCl, what happens? In presence of HCl, what happens? So here, H2O is removed. Here, H2O is removed. H2O is removed here. H2O is removed here. And you have to connect the oxygen to the carbonyl carbon. So what you will get? C, CH3, CCH3, and here O, CH2, O, CH2. Got it? So this is the compound resulting product we get from the given reaction. So it is given in option B. Option B is the correct answer for this question. Okay. Okay, next we'll go for question number 10. Next we'll go for question number 10. So the name of this compound is ketol. This is called as ketol. This is ketol. Okay. Now coming to question number 10. CH3 3 times CCl is reacting with NaCN and is forming compound A. Then compound A on dilute H2SO4 forms B and the compound B is. So what is compound B? So let me take the reactant. So it is CH3, C, CH3, CH3, Cl. This is the reactant. And it is reacting with NaCN. So NaCN is the nucleophile, Na plus and Cn minus. And the Cn minus is the strong nucleophile. Or we can say it is the strong base. So what the strong base will do? The strong base will go and take out or it will eliminate one of the hydrogen from the tertiary carbon. Okay. Since the system is the tertiary alkyl halide, instead of substitution, it will go and eliminate. So I can take one of the hydrogen out. So I'll take this hydrogen. I'll write this as CH2 and H. So the cyanide Cn minus will go and take this hydrogen. The bond shifts here and the CCl bond breaks and Cl goes out. What you are getting? CH3, C, double bond, CH2 and CH3. So HCl goes out from the reactant. Okay, so this is compound A. And this compound A on treatment with dilute H2SO. Dilute H2SO, basically hydration occurs here. So what is hydration? Hydration is addition of H2O. Hydration is addition of H2O. So how to add this H2O? H2O contains H plus and OH minus, right? Again, you have to follow Markovnikov addition. So break the bond and this carbon has 0 hydrogen and this carbon has 2 hydrogen. So the negative part goes to the carbon which has less number of hydrogen. So it goes here and hydrogen goes here. So it is CH3, C, CH3, OH and CH. Got it? So we are getting the tertiary alcohol from the given tertiary alkyl halide. So which is the correct answer? Option B is the correct answer for this question. So we will not get acid or ketone or all both, all the three. So we get only alcohol from the reaction. So is this clear? Just because the given reactant is a tertiary compound, elimination occurs. Okay. Shall we move on to the next question? Okay, I'll move on to question number 11. Carbonyl compounds undergo nucleophilic addition because of the statement type question. So carbonyl compounds undergo nucleophilic addition because of. So why does the carbonyl compounds undergoes nucleophilic addition? Give me the answer. Electronegativity difference of carbon and oxygen atoms. Is it because of that or it is because of electromeric effect? What is electromeric effect? So the transfer, a complete transfer of pi electrons towards or away from the nucleophile. That is called as electromeric effect. Complete transfer of pi electrons towards or away from the attacking agent, we can say, which is the nucleophile. It is because of electromeric effect or it is because of more stable anion with negative charge on oxygen and a less stable carbonium ion and none of the above. What could be the appropriate answer or the correct answer for the given statement? So on addition of nucleophile, so we get CO minus and the nucleophile carbon bond is formed and this kind of system we are getting, right? So the more stable anion with a negative charge on oxygen atom. The negative charge should be placed on the more electronegative atom only, that is the oxygen. Then only the compound is stable. And also the carbocation, the bond gets polarized first, right? We get O minus and the C plus. The bond gets polarized and then only the nucleophile attacks this carbon and finally we are getting this product. So the less stable carbonium ion is also formed. So the positive charge is present on the less stable, that is the least electronegative atom, which is carbon. Just because of this reason, the nucleophile goes and gets added to the C double bond O system. Okay. So it undergoes nucleophilic addition because of the more stable anion with the negative charge on oxygen and less stable carbonium ion. Carbonium ion is otherwise called as carbocation. Okay. So option C is the correct answer for this question. It is not because of the other two reasons which is given in option A or B. Just because of the electronegativity difference, the nucleophilic addition doesn't occur on carbonyl compounds, or it doesn't because of the complete transfer of pi electrons towards or away from the attacking agent. That is electromagnetic effect. Got it? So we'll go for question number 12. So which of the following compounds is formed when benzaldehyde is treated with CH3 MgBr and the addition product so obtained is subjected to acid hydrolysis? So what you will get when benzaldehyde is treated with CH3 MgBr and on hydrolysis? Primary alcohol, primary or secondary alcohol, phenol, tertiary butyl alcohol. So what is the answer? Just take your time. I'll give you 10 to 15 seconds. Try to find out the answer for this question. Okay, let's discuss. So all aldehydes except formaldehyde, that is except methanol, gives secondary alcohol. This is the concept. So all aldehyde means benzaldehyde also comes under it. Okay. So this is the benzaldehyde, C6H5CHO. So benzaldehyde is treated with CH3MgBr. Now how to add this Grignard reagent to it? So this is the negative part and this is the positive part. Break the bond, add MgBr to oxygen and CH3 to the carbon. So you will arrive at an intermediate and the formula for that intermediate is, okay, I'll write here. It is COMgBr and it is CH3 and H. So this is the intermediate we are getting. And this on hydrolysis, reaction with water. You have to break the OMG bond and add hydrogen to oxygen and OH to MgBr. So what you will get? It is C6H5CH, OH and CH3 plus MgBr, OH. So what is this? We are getting CHOH. CHOH is the secondary alcohol. So we are arriving at the secondary alcohol from the given benzaldehyde. Okay? Got it? If you are clear with the question, just give me a thumbs up. Okay, let's move on to question number 13. The final product obtained in the reaction. So you have to arrive at the last compound, that is the third compound. So in the reactant, carboxylic acid is given, propanoic acid is given. The formula for propanoic acid given here is CH3CH2COOH. And propanoic acid is treated with PCl3 first. So PCl3 is again a source to give out the Cl minus nucleophile. Okay. So the OH nucleophile will be converted to Cl nucleophile. So we get CH3, CH2, C double bond O, Cl. So this is compound number 1. And this compound number 1 on treatment with C6H6, which is called as benzene, in presence of AlCl3. It is anhydrous AlCl3. Okay. And it forms compound 2. So what is the name of this reaction? Acyl halide on treatment with benzene in presence of AlCl3. This is an electrophilic aromatic substitution again, which is called as acylation. This is the acylation. This is the acylation reaction. Okay. Acylation reaction. So in the acylation reaction, we get RCO plus as the electrophile. And this electrophile goes and attacks the benzene. So what we get? C6H5, CO, CH2 and Cl, CH3. So this is compound number 2. Got it? And then this compound 2 on treatment with NH2, 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 NH2 and with the base. Base means you can take OH minus ion from KOH and then you have to heat it. It forms compound 3. So what is the name of this reagent? It is Wolff-Kishner reagent, right? It is Wolff-Kishner reagent. So Wolff-Kishner reagent converts the C double bond O group to CH2 group. It converts the C double bond O group to CH2 group. I'll write the final compound here. So we get C6H5. It gets converted to CH2 and ethyl group is already there. So this is what we are getting from the given sequence of reaction. So this compound is compound number 3 and it is given in which option? It is given in option A. Okay. So can you be able to get it? Students, just give me a thumbs up. There is no response from your side for a long time. Just type S or give me a thumbs up so that I can understand you are listening. Thank you so much. Thank you. Okay. Then we'll go for question number 14 for today's class. Okay. The protonation of a carbonyl group increases its electrophilic character. And the reason is the protonation of the carbonyl group involves addition of an electrophile on nucleophilic oxygen. Just find out the correct answer from the given assertion and reason. The protonation of carbonyl group increases its electrophilic character. So they are talking about the C double bond O group and this group on protonation. So basically oxygen protonase, right? So we get C double bond OH and we get a positive charge here. So this protonation increases the electrophilic character they are saying. Tell me whether it is correct or not. Assertion is correct, right? So on protonation, the electron density on oxygen gets reduced and it withdraws the more electron from the carbon and it makes the carbon more electrophilic. Makes the carbon more electrophilic. That is more electron deficient. So the assertion is correct. And come to the reason. The protonation of the carbonyl group involves the addition of electrophile on the nucleophilic oxygen. Yes, the hydrogen, that is the electrophile, goes to the nucleophilic oxygen only. Reason statement is also correct. But just tell me whether the reason is the correct explanation for assertion or not. Both the statements are correct, but the given reason is not the correct explanation for the assertion. The protonation of carbonyl group increases the electrophilic character. That is okay. But what should be the correct reason? The reason should be it decreases the electron density and makes the carbonyl carbon more electrophilic in nature or more electron deficient in nature. That should be the reason. Instead of more electrophilic or more electron deficiency concept, they have given some other reason here. But it is the correct statement, not the correct explanation for the assertion. So, if both assertion and reason are correct, but R is not the correct explanation for the assertion. Okay. So, option B is the correct answer for this question. Then let's move on to question number 15. The major product formed in the following conversion is. So, a compound is there which contains two ketonic system, and this compound is reacting with NaBH4, which is the reducing agent. And NaBH4, we know that it reduces the ketones to secondary alcohols, right? NaBH4 reduces the ketone group to secondary alcohol group. So what we get first? We get CHOH, CH2, CHOH, and CH3. This is the compound we get on treatment with NaBH4. And then on reaction with H2SO4. And then on reaction with H2SO4 and on heating. So what do you get from here? So this is the acid, sulfuric acid, and acid contains H plus and HSO4 minus. So the oxygen protonates, both the oxygen gets protonated by the H plus, and we get OH2 on both the things. So CH2, CH, OH2 plus, and CH3. And then on heating, what happens? Water gets eliminated. Water gets eliminated here. So one of the hydrogen goes out. The H2, the HSO4 minus ion present in the H2SO4 comes and attacks this hydrogen, and the bond shifts here, and the OH2 goes out. And likewise here also, I'll write the CH2 as I'll write the H here, H2, and again the negative charge takes the H and the bond shifts here, and this OH2 also goes out. So what you get at last? We get a double bond here and CH here, double bond, CH, CH3. So this is the product. This is the product. So first you do the reduction with NaBH4. Then when the alcohol reacts with H2SO4, it gets protonated. Then on heating, elimination occurs with the formation of alkene, that is double bond. Okay. So this is given in compound option A. So option A is the correct answer. Okay, this is CH, CH and CH3 with double bond. Option A we are getting as a major product from the given reaction sequence. Okay. So I think this is enough for today. Let's take this question alone as the last question for today's class. It's very easy only. 2022 NEET question it is. To try to find out the product, a Grignard reagent is there, and it is reacting with carbon dioxide. That is C double bond O. C double bond O is reacting with RMgx and forms Y. Just break the bond and add the negative part R to carbon and Mgx to the oxygen. So you will get COMgx and R here, and one double bond is there. So it is O minus and Mgx plus. Okay, RCOO minus, this is R, CO minus and MgX plus. So this is the compound we are getting as Y. This is Y. So it is given in option A. Okay. Such an easy question. It is given in the preparation of carboxylic acid. You can go through it. So that's all for today. So do you have any doubt here? If you have any doubt, you can ask, or we can wind up the class for today. So you don't have. So if you're not having any doubt, then we can meet in the next class. Thank you, students. Thank you so much for listening.